Okay, let's consider a farmer has 2,000 yards of fencing to enclose a rectangular field. So the field borders a barn. So we're actually just going to use 3 sides of the rectangle with the fencing. The 4th side doesn't need to be fenced. And we're going to find an area function for this rectangle in terms of the width x, which we've already labeled. Okay, so let's think about how to build this function. Let's think about what we know, what's given, right? So we're told that we have 2,000 yards. So that means that 2,000 yards needs to do this, cover this, and cover this. So we already know that we're going to call this side x, so that means this would also be x, and we need to call this something else. I'm just going to go with y. So basically x plus y plus x, or 2x plus y, has to equal that 2,000 feet. Okay, what else do we know? We're asked to come up with a function for area. So I know that area of a rectangle, I'm going to use the same letters that we've used over here, is going to be x times y. But if I'm going to build a function for area, so a in terms of x, then that means whatever comes on this side of the function has to be in terms of x. So this x is okay, but now what I want right here is I want y, but in terms of x. And that's where this comes back into play. So I can just solve this equation. I know this relationship for y, and then I will have an expression for y in terms of x. So let's solve this for y. So I'll take that 2x to the other side. So that would be negative 2x plus 2,000. So that means y and negative 2x plus 200. Oops, I left out a 0. It's 2,000. Are the same things. So instead of x times y here, I'm going to put that expression in terms of x. Negative 2x plus 2,000, because that means the same thing. So now I have my function. So a of x is x times y, or x times negative 2x plus 2,000. So I'm going to go ahead and just distribute that x. So this is negative 2x squared plus 2,000 x. So notice I have a quadratic function. I have a negative lead coefficient. So I know this is going to be an upside down parabola. The questions are asking me to find the width that will give the max area, and then also the max area. So think about it. Let's talk input and output. We've got our function. What is the input? The input is x, which we know we're calling the width, right? So the input is x, which is the width, and the output is area, A. So every point is x, which is the width, and A, which is the area. So when I find that vertex, I will have width and area. The width that gives me the largest area. Okay, so let's practice this. This time, let's practice using the formula. So I know I could complete the square with this one, but we also talked about that formula for vertex, where the vertex will be negative b over 2a, and then f of negative b over 2a. And of course, that's when we're looking at a quadratic function, just in general, ax squared plus bx plus c. So the b's and the a's come from the same place that the quadratic formula would be. Okay, so in that case, we'll say, okay, so for the input value, we'll do negative b over 2a. So in this case, that would be negative 2,000 over 2 times a is negative 2. So that would be negative 2,000 over negative 4, which would give me 2,000. Or 1,000. I just said that wrong. I cannot do simple arithmetic. No, it's neither. So let's see, 4 would go into 2,000 500 times. There we go. That's better. So that would be the input of the vertex. So now to find the output, I'm just going to run that number back through the function. So let's see, this would be negative 2 times 500 squared plus 2,000 times 500. Okay, so let's see. This is going to be 500,000. Okay, so that's this. Okay, so now let's see what we can do to answer these questions. So what width will give the max area? So that would be 500, and let's use the correct units. So that would be yards. And then what is the max area? That would be this, the output. So that would be 500 yards squared. So that will conclude our lecture on applications. Thank you for joining us, and we'll check back soon.